Okay, the fundamental theorem of calculus, part 2. So if we've defined a of x to equal the integral from some number a up to x of f of t dt, at this point we should be getting down that derivatives and antiderivatives are kind of opposites of one another. So let's think if we took the derivative of the left-hand side with respect to x, that would mean the same thing as a prime of x. Okay, I think that's pretty straightforward, but if I do the same thing to the right-hand side, the derivative of the right-hand side with respect to x, and remember, taking the derivative and taking the antiderivative are opposites of one another, what's going to end up happening is we're going to be left with whatever is on the inside. So whatever's on the inside here, you can basically think of that as being the derivative of the initial function. Okay, now we do rewrite it because our variable here is an x, we do say f of x. So let's give this a shot and we'll look at it with functions, then we'll look at it with some graphs, pretty easy questions. So running right through here, if we define a of x to be the integral from 0 to x of 2x dt, 2d dt, our goal is to find a prime of x. So remember, all you're doing is you're looking at what function do we have on the inside here, but because we have x is our upper bound, we put 2x. That's it. You replace the t on the inner function with that x up above. And that's the derivative of a of x. Well, let's try it with this one. All right, integral from 0 to x, 3 minus t squared dt. Whatever's on the inside here, the derivative of a can be written as that same thing, but instead of a t, an x goes in its spot, and that's the derivative of a of x. All right, so what about on a graph? What does that look like? Okay, so in this case, they've defined big F of x to be the integral from 0 to x of f of t dt, where little f is graphed below. Okay, so they gave us the graph of the derivative here. So what we want to do is estimate f prime of 3. Big F prime of 3. Well, it's important to note that means the same thing as little f of 3. Right? Whatever's on the inside is the derivative. Okay, so looking at the graph, they gave us little f's graph. We have an x value of 3. The point on the graph looks to me like it equals 0. If you know how to read it, it's not that bad of a question. Last one. They define a of x to be the integral from 0 to x of f of t dt. So remember, whatever's on the inside here, that's the derivative. Right? That is a prime of x equals f of x. Well, they gave us f of t's graph, or you can think f of x's graph. One and the same in this case. So, using that graph, can we find a prime of 1? Well, I hope so. So a prime of x is the same thing as this graph that's given to us over here. So we go to an x value of 1, find the point on the graph, and no, we're not looking for the slope of the line. All right, what we're looking for is the y value that's coming out. All right, this is asking the same thing as what is f of 1. A prime of 2, well, you look for the point on the graph. This one's going to work out to be 2, not the slope of a tangent line or anything like that. And finally, f of 3, we're looking at that point on the graph. That also works out to have a y value of 2. Remember, this was the same thing as saying what's f of 2, what's f of 3. All right, so hopefully this helps out a little bit as you're working on understanding how derivatives and antiderivatives kind of fit hand in hand. Good luck.